I'm just waiting for your friend.
Oh, okay.
Emma also is joining. Just a
Hello.
minute. Hello.
Hi.
Hi.
Good.
Just hold on.
Yeah.
Today we'll begin with JUnit testing.
Okay.
Yeah.
Were you able to plug that log4j into your application?
Yeah, I started, but I haven't finished yet.
No problem. You can take time and do it.
Yeah. For me, I have a confusion somewhere
What confusion?
on the log4j dot property file.
Log4j dot properties file.
Yeah. So you say
What's
that
confusion?
we have to implement the code you gave us those like
Right.
So I was wondering, some of them I really don't understand why, or
Where
the
I'll
way
open
you
that slide.
said, yeah.
Right. I'll open that slide. Which one could not understand?
On
There
the
are slides.
log4j properties.
Yes. Log4j dot properties.
Yeah.
This one.
Yes. Yeah, that one. This
Yes. What's
org.apache log. Do we have to implement as it is?
look? This one you have to copy paste from a sample that is available on web. Just
Yes.
open. I told you to open and type for sample. And open this any link, and you have to create a notepad with name log4j dot properties.
Yes.
It's taking time to open that file. You just need to put these lines in the notepad and save it. That's it.
Okay. We don't have to edit something or
Edit in the sense?
for
Make
example,
some changes.
Come again?
make some changes on what we copied from the internet.
You have to, because these are different and whatever you copy from internet will be obviously different, right? You can see here.
Okay.
I want to say. From internet, whatever, it's a sample file. It's a sample file. I told you, same one. To copy this, put in notepad, and wherever there are values, you put the values that are present in the slide.
Okay.
Yes, you put these values, blue color text.
Yes.
And you can refer to this because if you keep typing that, you may make mistakes while typing. So I ask you to copy and paste a sample from.
Got it.
Okay.
Right. Anything else?
No.
Fine then. You make it right.
Thank you.
And sure you can do that.
Yes.
And I'm talking about JUnit, right?
Okay.
Okay.
So JUnit is a unit testing framework for testing the program developed by the Java programmers. So here the thing is, you will be developing an application. Your application has to be tested against the requirements what you are working. So your code has to match the results that are expected as per the requirements. Suppose your code is not giving the results as per the expectation, it means there is a bug in your code, right?
Right.
Yeah.
So you need to correct that. Generally, we have a testing team in a project who will perform the testing functionality on the code developed by the programmer. So if you get into the SDLC lifecycle phases, so you are fine. Right here, SDLC. That is today's date. It is 10th October, not 5th October. Software development life cycle it is. So can you name the stages present in this? Do you know about the software development life cycle?
Yeah.
Can you name the stages available in it?
Gathering the requirements.
Right. Requirement analysis phase. Right. Next.
Implementation.
Right, implementation. Implementation is nothing but coding. Next.
Testing.
Which one? It should come in order. Testing.
Deployment.
Right.
I don't remember. Yeah, maintenance. I don't remember the second one.
Then phase.
Oh yeah.
So here you will be making use of that UML diagrams.
Yeah.
The activity diagram, sequence diagram, component diagram, class diagram. Right, these things, right?
Right.
So your client would be giving requirements, and these requirements are mentioned in some standard documents. In an organization, it would be using their own standard documents, standard documents. So, based upon the requirements, the design experts will come out with some UML diagrams, class diagrams, sequence diagrams, talking about the functionality of the application.
Of the application, yes.
Right. By looking at this design, the programmers would start coding. Okay.
Yes.
Yeah.
Once the code is developed by the programmer, that code is to be tested by the testing team.
Team, yes.
And everything also, every piece of code will be tested. If there is a bug, then the testing team will address that bug, and you programmers have to rework on it. So it's a iteration process.
Yeah.
Until the bug is removed from the code, it continues. These two things continues.
Yeah.
Then once everything is done and the code is matching with the results as per expectation, then it goes for deployment. That is configuring your project at the client location.
Yes.
Then client starts using it. While using it, he may be having some
problems. Yeah, some issues.
Some issues, some additional requirements. Those are addressed by the programmers in maintenance part.
Yeah.
Till this part, it is application development.
Yes.
And this part is maintenance. Yes. So this testing, I told you that there is a testing team. There will be a testing team. So testing team will be performing testing using various methodologies, maybe manual testing or automation. So they will be by using various tools for that, maybe Mercury, WinRunner, Load Runner, QTP, Quick Test Professional it is, Quick Test Professional.
Okay.
Silk Test. So these are the various things that are used by testing team.
Yeah.
So we programmers also can perform testing while we are coding.
Yeah.
We perform the testing using JUnit.
JUnit.
Okay.
So we are looking into this JUnit now.
Okay.
So JUnit is a unit testing framework, and JUnit can be used to test the applications that are developed by Spring, EJB, Hibernate, web applications, Servlet, JSP, Core, Java, all this. That is Java related things.
Yes.
So JUnit is important in development of test-driven development. So what this test-driven development is? So test-driven development means you are going to code that, immediately test it. Code it, test it. Code it, test it.
Okay.
So this goes. So why do we go for JUnit? So it's an open source framework that is low cost, which is freely available. Then integration testing with ease. So that is, there will be a team of developers working on a single project. So their code can be integrated and tested. So code developed by one person can be integrated with the code developed by the other person in the same team. So after integration also you can perform this testing. So this JUnit will identify any broken functionality in the application and improve the quality of building, unit testing, regression testings, all these things. So here there are various testings, testing the functionality, that is what UAT, user acceptance test, regression test, integration test. So these are various testing methodologies. So all these kind of things can be done using JUnit. So that is why industry is preferring JUnit.
Okay.
And you can see the key JUnit elements are test case class. So a class which contains the test case methods for testing the component.
Okay.
For example, I have a program basic calculator which will perform addition, subtraction, multiplication, division, assume.
Yeah.
Then you can see here a class is generated test basic calculator which would test the existing class.
Okay.
So here test basic calculator. So let me show you the piece of code here. I think it's right. Here you can see the calculator class. Calculator class is having add, which would take numbers and perform an addition.
Yeah.
And return the summation.
Long. Yeah.
Likewise, divide, which takes two numbers, maybe it gives the result. Okay.
Yeah.
Okay.
So here a calculator test. So here you can see a calculator test. So I mean program name and I mean this is the class name and the class name is test, which has the piece of code like you can see add is the method present in our calculator program, right? This is the program written by the programmer.
Yeah.
This program has to be tested using JUnit. Okay. This is the code with JUnit integrated. So add is the method name in the calculator. You can see here test add. So it means that we are performing a test on the add method. Okay.
Yeah.
And here in this you can see assert equals. It's a method. It's a method which would take two arguments. You can see here first argument, second argument, right?
Yes.
Second argument is the thing after evaluation gives the result and this result is based upon your code.
Yeah.
You can see here calculator program reference here, right?
Yeah.
On this calculator program, add method we are invoking right 3,2.
Yeah.
So in your piece of code calculator program, add method which takes 3,2 and results 3 plus 2. What is the result? 3 plus 2.
5.
So I am giving the first argument. So when I know that when 3 and 2 are passed, the summation of 3 to 2 is 5. I know that. So your result given by the programmer should match with my first argument. Got it?
Got it.
If it is, then this assert equals will return true.
Okay.
If not, it's false. Got it? So
Got it.
your program here should return the same 5 and added 3 plus 2. Instead of 5, if it is returning 6, 7 or something else, it means that your logic is wrong, right?
Right.
Okay.
So likewise for a test divide. So divide is a method. So test divide. So to this assert equals second argument you can see on the calculator add should not add, it is divide. A mistake here. Typo. Divide 4 by 2. 4
Divide.
The result should be 2.
2.
Apart from 2, if it is returning something else, it means something went wrong with your program. Got it?
Got it.
Yes. So here, test case method, a method implementing the test case. So a component method translates to many testing cases. You can see test add positive, add negative, add zeros, add maximum. These are known as test case methods. For us in the calculator program, that is test add, test divide are the examples.
Okay.
Okay. We call them as test case methods.
Okay.
So this is a test case class, and here you can see a fixer method. So these are terminologies present in the unit testing. So here, what this method is doing, so create an object for our calculator class. Create object. Okay.
Yeah. Yes.
Yeah.
And here, at the rate, before class, at the rate test, at the rate, all these are annotations. The JUnit which we are discussing supports annotation also. Okay.
Okay.
Yeah.
Test method. You can see a test method. So these are the terminology: test case class, fixer, test method. Got it?
Got it.
This is our program which we have written as per the client requirement.
Yeah.
This program is tested with the JUnit here. Got it?
Got it.
Got it.
So there was JUnit 3 and JUnit 4, the current version.
Okay.
This JUnit 3 test class must extend test case class. I mean, it was the previous thing. So you need to write your class and extend test case. Here, test class has no need to extend. We don't perform that extending this test case something kind of here. All test methods must start with the word test here in the older version. So as a result of annotation, you can write just at the rate test annotation. And if you see in our sample piece of code, it is at the rate test, right?
Yeah.
Annotation. So use setup and tear down as fixers. So setup and tear down are some methods that are used to execute with the JUnit 3 version. We are using JUnit 4, so we have annotations. So here fixer methods can be annotated using before execution, before class, after class annotations. Okay.
Okay.
So flavor of assertions. All these assert methods are generally used for testing. We have seen assert equals,
Yeah.
which would give a Boolean value based upon the code written by your calculator program add method, right?
Right.
So likewise, you have assert null to check the null value. Assert not null, whether it is not null. Assert true. Assert same objects. Assert that. So all these are assert methods we generally use in JUnit testing. So here, assertions are used to check whether the actual test results are the same as expected results. Assertion is nothing but our assumption. Okay? You can see here, assert equals method is taking two arguments. The first argument and second argument. Second argument is we are calling the code that we have written. So calculators add method, right?
Right.
And we are passing the arguments 2, 3. I am assuming that 2, 3 when passed it should give 5, right?
Yeah.
Right.
So assert that method add output should be equal to the expected 5. If it is not resulting to 5, then this assert equals method would return false.
False. Yeah.
It means that your code is failing, right?
Yes.
It's not as per the expectations.
Okay.
So likewise we have failed. So this is used for failing the test case under specific condition. Yes. Can be used inside exception blocks and can be used to fail the test case under some conditions. You can see here. So here, try catch block test division. Some object dot divide 5, 0. When 5 is divided by 0, definitely an exception occurs, right?
Yeah.
Right.
So here we are failing this test case, when 0 is given as the second argument for divide, fail with arithmetic exception. Okay?
Okay.
With this message,
Okay.
with this.
Yeah.
Mm.
So assert equals. So here you can see. Assert equals. This is used to assert that the actual value is equal to the expected value. Okay?
Okay.
You can see here, assert equals take two arguments. If this is expected and this is the actual, that is coming from your code.
Okay.
But expected and actual
Right.
means the difference between actual and expected. Actual is nothing but the things that are coming out as a result of your piece of code.
Okay.
Expected is your result should be giving the results as per the expectations that are set in the business requirement analysis.
Yeah.
Okay.
Then when this assert equals is generally used to compare to primitive values, compare to wrapper objects, or to compare to user-defined objects, we use this. You can see here, assert equals is taking three arguments here. So values are equal a message 5 comma add 2 comma 3. So the last one add 2 comma 3 is resulting based upon your code, right?
Right.
It should be equal to 5. If it is okay, then values are equal would be printed, right?
Yeah.
And assert same. So here you can see assert same is used to assert two objects referring to same object. Now assert same, if you want you can give a string message, comma, object expected, comma, object actual. Okay?
Okay.
And then it is used to compare to wrapper objects. And to compare to user-defined objects, we use this. String s1 equals to hello, string s2 equals to hi. And you say,
Okay.
assert same, some message, comma, s1, comma, s2. This piece of code, assert, is going to check whether objects s1 and s2 are same.
Okay.
Are they same?
No.
They're not same.
They are not same, right? So assert null. This is used to assert whether the object is null. Okay?
Okay.
Assert null, to this you are passing an object. And when it be used? So to verify whether an object is null or not, we use this. You can see here, a user bean is created, right?
Yeah.
Right.
We call the bean as a transfer object or value object, which means the same, right?
Right.
String s1, one string is created, assert null. You can see here, you are passing and the object here. So user value object, that is Vivo, is null. So you are passing the object here. Okay?
Okay.
If it is null, it displays this. Right?
Right.
And here also you can see assert null. So S1 is of course null, right?
Right.
Yeah.
Whereas value Vivo object, this is not null, right? Because it is pointing to some object.
Yeah.
Yeah.
Right. Assert true. This is used to assert whether a Boolean value is true or not. So here you can see assert true, which takes two arguments, message and a Boolean condition.
Okay.
When we use this, when a method returns a Boolean value and needs to be asserted, tested. So here you can see Boolean flag, he is Indian citizen. So this is a method call. This may be returning either true or false, right?
Yes.
Right.
Mm-hmm.
So accept true. So here you can see this flag value. Okay.
Okay.
So if the flag value is true, then it displays a message. It fails. How it is failing everything we can see graphically with Eclipse. I will show you that.
Okay.
Okay.
So this will throw an error if the flag is returning a false value.
Mm-hmm.
This one.
Yeah.
So here asserts that actual satisfies the condition specified by a method. So here you can see assert that. So there is a message string message, and here you can see T actual, and there is some matcher here. Third argument.
What is it? A matcher?
Look at the example here. So when a readable and flexible text using the value and matcher patterns, so the thing is accepted. So we have an assert true, right, previously?
Yes.
So assert true, what it does, you can see there is a string. We are going to check contains a color over there, right? Contains a color. Or response string contains color. So here the thing is, this can be written using assert that a string, first argument. So any of the color here, you can see here any of the color. It means we are trying to match with any of the color. Got it?
Got it.
So contains string color. So contains string color. This any of this. You can see any of method which is taking two arguments here. Contains string color, comma contains string color. Got it? So the same assert true can be written like this by using assert that. So here we are matching with a set of values. Got it?
Got it.
Yes, that's about test. What is that? Methods present in the JUnit. We will go by example. So my Word file. So current version 4 we are using, and all these are present in a package org.JUnit package.
Okay.
So it contains interfaces and classes for performing the JUnit.
Okay.
And so I told you that types of unit testing may be manual or automated.
Yeah.
So we will be looking into manual, because once we are comfortable with manual, automated becomes easy.
Yes.
So annotations. So there are annotations, right? JUnit 4 supports annotation. So here, @test annotation specifies that method is the test method. So it means this is the method we are going to perform a test. Test add was the method, right, for us?
Yes.
Yeah.
Was the
Yeah.
method
So
for us.
we will be activating it as @test. So this is the method to be tested. And @test timeout some seconds. So annotation specifies that method will be failed if it takes longer than these 1000 milliseconds.
Yes.
So timeout is an attribute which is taking some value milliseconds.
Yes.
And before class annotation specifies that method will be invoked only once before the starting of all the tests. Okay.
Okay.
Method will be invoked only once.
Yeah.
And before starting all the tests.
Yeah.
And before, before, annotation specifies that method will be invoked before each test.
Oh.
And method will be invoked only once before all the test cases.
Okay.
Then after annotation, specify that method will be invoked after each test.
Okay.
Then after class, before class, after class. Annotation specify that the method will be invoked only once after finishing all the tests.
Yeah.
Okay.
Then assert class is present in jar.junit assert. So it is the package name and assert is the class.
Yeah.
So this provides all the methods which we browsed through in our previous slides.
Yeah.
So assert equals, true, false, null, not null, right?
Right.
So we need to have this JUnit 4.jar file. We need to download it and configure it with our project.
Yes.
Yeah.
Okay.
Yeah.
Okay.
Ignore this, the other one. I just copy pasted this from Google, so ignore this other one. We will focus on this.
Okay.
Okay.
So simple JUnit example. So this is, you can see here the project name
Yes.
Yeah.
and source. So package with the class name, calculator.
Yes.
Okay.
Yes.
So your test cases should be in a different package. You can see test case, test logic. Okay.
Okay.
And so we will write the program, this program whatever present here, and perform the testing, the same program. Yes. I will write the program here. Simple program, it is calculator program. So here you can see calculator, and it's a static method, find maximum. For this we are passing an array, okay? And inside this find max, the code is maximum is given as 0 value, and we are going to navigate across the array, and if maximum is less than the first element, then you can see here 0 is less than this, then take this array value and put it in maximum. Got it?
Got it.
So I'm finally returning max.
Yeah.
So I'll write this program. My Eclipse, I think I did not launch Eclipse. Let me launch Eclipse. So then we'll write a test case, JUnit 4. So as we are using JUnit 4, we don't need to write our class that will inherit test case, which we used to do with the JUnit 3 version.
Yeah.
So the main testing code is written in test find max.
Yes.
That is, find max is our method name, and we need to prefix with the test test.
Yes.
Test string with our method name. So we will be using before and after each test annotation. So here you can see test logic is the class that is going to test our code.
Yeah.
Find max, you can see here at the rate test we are using, which means this is the method we are testing. Okay.
Yes.
And we are writing assert equals find max and provide some array. Out of this array, 4 should be maximum, right?
Yes.
Right.
And here I give some array, and -1 should be the maximum. All are negative values here, right?
Okay.
So we will execute this and see. So there will be a what is the progress bar here, JUnit progress bar, which will be turning into green color once our test cases are successfully done.
Successful. Okay.
Here it's red in color as of now. I'll show you this.
All right.
Then we are correcting the program logic to find the maximum. So here you can see. So maximum, we are correcting the logic, then we are re-executing, and the bar turns to green in color.
Okay.
right? So I'm going to create a package, a project, core Java project. So Java perspective, so I'm creating a package here, a class, calculator, and in the package, JUnit demos,
Okay.
right?
Right.
So the method find maximum. I'll just copy this piece of code. If you observe, there is no main method over there.
Yeah.
Please hold on, I'm getting a call, let me answer.
Okay.
Yes, I'm back. Okay.
Okay.
You can see here find max is the method, which is a static method, and this is the piece of code. So we define a max value is 0, and we have written some logic to find maximum of an array. And if the maximum value, what is the local variable? If it is less than this array elements, then you can see here the array element is given as the maximum.
Okay.
Now I am defining another class, test logic, and it is present in test case package. Here also I don't need a main method. Okay. Then you can see test logic. So I am making use of this piece of code.
Yes.
And let me remove this. So I need to format this and calculator or program name. So I give calculator here. Calculator, and I need to import that.
Yes.
and here also calculator. Right. And I'll format this code. Right click, go for format. Right. So that the code is well organized. So at the rate test, you can see here test cannot be resolved to a type. And here add JUnit library to the build path.
Okay.
So Eclipse is intelligent that the at the rate test annotation is from JUnit 4 framework. So it is giving a suggestion. Do you want to add this JUnit to your library path, build path? Yes. And here I have JUnit. Right, JUnit jar file. Okay. So the Eclipse has these jar files automatically. I mean, we are using advanced Eclipse, right?
Yeah.
Right.
So the method assert equals. So undefined for the test logic. Static import. Okay. We need to because this assert equals is present in r.JUnit assert, right?
Right.
Right.
Right. Now there are no errors. The thing is, if you want to configure this JUnit with the older versions of Eclipse, then you need to actually download this JUnit jar file. Okay.
Yeah.
So here there is JUnit 4.8.2 jar file. Okay.
Yeah.
So you need to download it by googling out. Okay. Type JUnit jar file, and you can download it. From Java to AS. So you can see a JUnit jar file. And if you want, you can go for the latest version, 4.3 something it is. It is JUnit jar. If you want, you can download the what is it? Latest one. You download it, and the same. How do you do that? Right click, properties, build path.
Yeah.
Build path, libraries, add external jars. Same which we have done the step with the MySQL connector, right?
Yes, right.
So my Eclipse has already those inbuilt jar files, so it is able to configure it when I used a suggestion that is given by the Eclipse.
Okay.
Then execute this. That's it. You can see a run as previously was you are displaying run as Java application, right?
Right.
Right.
Now I am executing my test logic program. Right click, run as JUnit test, you can see.
Oh.
Got it?
Got it.
Execute this. You can see here there is a red color bar.
Okay.
Which shows that my test case here, you can see there is a cross mark here. So take this, and here you can see this is failing. Okay. Got it? This is failing. This is failing. So and here what is my Eclipse? You can see here failure trace. Java.lang assertion error expected -1 but was 0. The reason for failure. We gave The max value is 0, right?
Right.
In our piece of code. So finally it is resulting 0, but when you supply negative values, it should return -1, right?
Right.
So that is why it is failing. Got it?
Got it.
Got it.
So correct the programming logic. So it means your program is throwing an error. So I am going to correct it. I am taking the first element instead of 0. Got it?
Got it.
Take this. Go to your calculator program. So instead of this, right. I am considering the first value as the first value from the array. Okay. Got it? It means our program is now corrected. Now go for test. Right click. Run as JUnit. Now it's green in color.
Yeah.
Okay.
And here you can see there are no failure traces.
Yeah.
It means our program, whatever we have written, is working well done.
Yeah.
And we tested it by using this.
Yeah.
Got it?
Mr.
Yes.
What if we don't want to use the numbers? Like over there we put 4 and yeah.
If you don't want to use numbers,
we don't like, we want to like use input parameters which we input and then check if our program is working correctly.
Suppose int k equals to 4 I give, and do you want to give k here? Do you mean that?
Yeah.
Yeah. Okay.
There is nothing wrong in it. Here I gave it hard-coded value. Generally, we know that the result would be 4, right?
Yeah.
Yes.
So I gave directly 4 over there.
If you want, we don't know the result, but we want to check. If we don't know the result, let's say we want to enter our...
Look. If you don't know the result, will you be able to test?
No.
Okay.
If you don't know, how can you test it?
Okay.
You should know the result, right?
Yeah.
Okay. Yeah.
How can you say whether it is correct or wrong?
Oh, okay.
It means that you should know what the actual requirements are.
Okay.
So you will be certain when you study the requirements from this SDLC phase.
Okay.
So when you study this requirement, then it is sure that you know that. Then your piece of code should give the same as per the expectations.
Okay.
Mentioned in the requirement analysis.
Yeah. Okay.
Right. So there is no case that when you don't know.
Okay.
So here there is another piece of code. I'll explain you, and I am expecting you to execute this by referring to my Word file. Okay.
Yes. Yeah.
So there is test case 2 class. So here before class annotation is being used. Okay.
Yeah.
And some message we have written before class, which means whatever the thing you are doing inside this setup before class method would be executed. Got it?
Got it.
Got it.
Before the setup method. So here, before would be executed. Likewise, test to find maximum. Okay. So for the same calculator program, This is the second test case. Okay.
Yeah.
Okay.
Find max, you are passing an array, and find max another array. Okay.
Yeah.
And there is just a cube, a method, so which is going to calculate the cube of a variable. Let me check. Is there that cube method? Yes. I missed this calculation. Where this is okay. Another new method they have inserted here along with that find max. Okay. Finding the cube.
Okay.
Cube. It takes number, performs the cube and returns it. Okay.
Okay.
Another method also they introduce reverse word.
Yeah.
It string, and here reversing the string logic goes here. Okay.
Yeah. Yeah.
And finally, it is returning the string after reverse. Okay.
Okay.
Yeah.
So we are testing those pieces of code. Test reverse, test cube, got it? At the rate annotation, right? Got it?
Yes.
And we are just printing a message system.out.println. Test case reverse word we are executing.
Yeah.
And here we are passing a name, passing a message here. Okay. After reverse, it should be like this.
Yeah.
Right?
Right.
If not, the bar would be red in color.
Yeah.
And here after annotation, some message, it says that this would be executed after the method execution.
Yeah.
And after class, all the test cases are done, then this gets executed.
Yeah.
You can see after class message output also they are given. Before class gets executed, before all the test case methods. After class executes after all the test case methods. Right?
Got it.
So can you do this?
Yeah.
Yes.
Fine then. With this, I am closing my session. All right.
All right.
Okay.
And we'll meet tomorrow.
Your
5
morning.
a.m.
Yeah.
My morning.
All
Yes.
right.
Okay.
Okay.
All right.
Thank you.
I'll email you this, and you finish that log4j sample also. Meanwhile,
Yeah.
if you don't find some time, take another day and finish. No problem.
Okay.
Okay.
Fine. See you. Welcome.
See you.
See you. Bye.
Bye.